This is a picture of an SA-2 site situated in the immediate Hanoi area. A close-up of this particular target would look something like this. Very clearly, you can observe the presence of SA-2 missiles. And in this area, we find the radar van which controls the firing of the missiles and also tracks the aircraft along with providing guidance to the SA-2 missile. Our pilots are constantly faced in flying into North Vietnam with missile firings along with extremely heavy anti-aircraft.
It's just when you get down in the Delta in the flatlands, that 30 mile ring around the city of Hanoi is a bear. Because it's flat, you have no protection. And, I don't know how true it is, but they say it's the most heavily defended place in the history of aerial warfare. I've been there and I believe it.
The area in North Vietnam is without a doubt the heaviest defended that I've ever seen. And all along their lines of communication, and particularly around Hanoi, it's very, very heavily defended.
On some of the missions over North Vietnam on this present trip, I've seen some fire as intense and as accurate as any I've seen in the past.
Mayday, this is Red Rooster Lee. My wingman's been shot down.
There is little more that this pilot can do to affect what happens to him now. If he is not recovered during the next 10 or 15 minutes, the chances of doing it at all become increasingly remote. This man is ready to be recovered now. This fighter has survived. If it had an air retrieval capability, it could make the recovery now. This man is still ready to be recovered now, before the hostile ground forces have reacted and mounted an effective threat. This fighter has survived. If it were capable of such a mission, it could make the recovery now. This man is still ready to be recovered now, before the hostile ground forces arrive. If this aircraft could land here, the recovery could be made now. These men probably could have been recovered had one of the aircraft which had the opportunity had the capability. During the last 4 years, a system was developed and demonstrated which, given the opportunity, has the capability. It works, it is here, it can do this mission. In response to the urgent Air Force CARA RFP, the Ryan Aeronautical Company has proposed the Model 230 CARA, based upon the proven technology of the lift fan propulsion system and on XV-5A demonstrated capabilities. Extensive operational analyses of modern combat situations and extensive first-hand testimony have shown that there are 5 basic criteria which determine the effectiveness of a combat aircrew recovery system. These criteria are rapid response, survivability, flexibility, compatibility, and vertical performance. Rapid response denies the enemy the time in which to react and to mount the threat. It reduces the chance of survivors' capture and greatly reduces the problem of survivor location and identification. Analysis of operational data have shown that current system response is such that no recoveries from hostile territory can be made during the first critical 10 or 15 minutes. and that several hours or even days elapse in most cases. Rescue and combat crews are all agreed that response time is the single most critical factor in the success of the recovery mission. The Ryan CARA offers on-the-spot reaction combined with a 535-knot low-altitude dash speed capability. The Ryan CARA offers a 300% increase in speed and an almost infinite reduction in response time. In order to respond rapidly in a severely hostile defensive environment, the recovery aircraft must live near the strike area and be at least as survivable as the strike aircraft being accompanied. This can only be achieved by a high-performance fighter design philosophy. The Ryan CARA has typical subsonic fighter performance and maneuverability characteristics. In order to respond to a variety of recovery situations, the recovery vehicle must be capable of air-to-air, air-to-ground, air-to-sea, and ground-to-ground recoveries. The Model 230 CARA incorporates all these capabilities without prejudice to response or survivability. Systems permitting night and bad weather operations have been incorporated. Remote site deployment is made possible by an APU and hydraulically driven electrical systems. Compatibility with the strike force in terms of size, range, speed, maneuverability, and in-flight refueling are all essential to homogeneous strike escort operations. Any compromise of this criteria results in a response penalty and consequent reduction in mission effectiveness. The Model 230 CARA offers this compatibility and a large reduction in the size of the recovery task force. The preceding criteria, although vital to the effectiveness of the system, are of little value unless backed up by a credible and realistic vertical performance. This includes rescue capability, stability and control, hovering performance, hovering time, rescue payload, and total mission performance. Rescue tests on the XB-5A demonstrated satisfactory environmental conditions beneath the aircraft, with temperature, downwash, and loads well within satisfactory limits. The United States Air Force Flight Test Center bioastronautics personnel participated in the test, and they were satisfied that the environment was satisfactory for a human lift to cockpit level. The XB-5A demonstrated ability of lift fan systems to operate vertically from any surface capable of supporting the wheels, and the satisfactory downwash characteristics of this system have assured a credible CARA rescue capability. Both hovering and landing recoveries can be made, in addition to air retrieval. 97% of the recoveries made in Southeast Asia have occurred at altitudes less than 4,000 feet and 84 degrees Fahrenheit. The Ryan CARA unrefueled design mission hover point is 6,000 feet and 95 degrees Fahrenheit. 90% of the recoveries where data was available required 15 minutes of hover time or less. The Ryan CARA design mission hover time at 6,000 feet, 95 degrees Fahrenheit, is 15 minutes. At 4,000 feet and 84 degrees Fahrenheit, 30 minutes is available. 96% of the recoveries in Southeast Asia involve 2 or less survivors. The Ryan CARA unrefueled design mission pickup at 6,000 feet and 95 degrees Fahrenheit is 3 men. 5 can be accommodated under conditions where range and density altitude permit. The design mission unrefueled radius of action of the Ryan CARA is 367 nautical miles. This mission can be performed with a vertical takeoff at sea level or a STOL takeoff at 2,000 feet and 95 degrees. It includes 15-minute search, 15 minutes of hover at 6,095 degrees with a 3-man pickup. A quick-attached jettisonable armament fuel pod can be used for an alternate 5,000-foot 95-degree pickup mission, which extends the unrefueled radius to 420 miles. Refueled missions will provide an infinite variety of range and endurance capabilities. 6 Ryan CARA systems can be delivered IOC in 36 months from go-ahead, based upon production of 10 flight vehicles in an accelerated test program.